Good evening, everyone. Today, I'd like to present the Ethereum virtual machine, abbreviated as EVM machine. Actually, the EVM machine looks like this. All the Solidity code actually eventually is compiled to a bytecode, which is executed over the EVM machine. It's a stack-based machine, so stack is very important over here. You have the program counter, you have the gas available, and you also have the memory, but the code is immutable. And the memory can be changed, the stack can be changed, program can be changed. Of course, gas will be reduced, and then state variable will be stored in the storage. It's going to be the memory is going to be temporary, but the storage or the state variable is going to be permanent or persistent. So with that, let's go to the Ethereum remix over here. IDE online. I create this simple program already, so just want to show what the EVM looks like. Very simply, don't be scared. So I already compile it. So if I want to deploy, I can deploy to a local machine. So even the deploy is a function that executes over the virtual machine. So I actually can debug it by see the deploy how it works. So let me see. You debug the deployment function. Immediately you see a lot of panel. This one shows you the stack. This is the one we're going to focus today. This one shows the local variable. This one shows the state variable, which is permanent in the storage right now. It's 0. So because we have not fully deployed it yet, it's debugging. And then let's see. So let's say go to this. In the beginning, usually it's going to save 8040. Actually, what this is doing is trying to let's look at the memory part. This is a term for memory part actually. Okay, this is actually doing memory allocation. So in particular, it's going to store this 80 value at the location of 40. What is this doing? Basically, is the indicate the memory is going to start from 80. Before 80, oh, by the way, 80 is a hexadecimal. So before 80, they are all reserved. Okay, that's what it's doing. So I'm going to move very fast forward. So SSS store basically store that value in the memory. So, and as you can see, the gas is also reduced from the beginning. And it's checking also, you can actually stop that because this is just simulation. So the core value is basically the MSG value. The amount of Ethereum is sent to a contract. We are going to push on the stack twice. Duple one means duplicate stack 1, stack 0 means the top, stack 1 means the one next to the top. Just push twice because we are going to pop it later. So we check if it's 0. So when we check 0, it's going to automatically pop up. So that's why we put it twice. So check 0 and check with 0 and see if anybody sending in Ethereum. If it's yes, then deployment is going to revert, I believe. If not, then you go to the normal case. So I'm going to go very fast over now. So then I'm going to push. Oh, I'm sorry, I'm going too fast over here. I do. Okay, step into this, deal 1, push 2, deal 0, push 0, push 0, and then we code a copy. So this is very likely copied by the code into memory, and then push 0 over here, and then we return. So then we are done. Okay, so the memory is initialized to 0. So let's go back to something else. Let's say we're going to store another number over here. And by the way, because I declare public, so the compiler is going to automatically generate another function called number, which is a getter. So I can get the value and I can choose to 3 store, then immediately this will become 3. And if I change to 5, I'm going to debug this one, 5, and this should be 5, 2, which I'm going to do later. So let's debug the case that I set to 5. And so it's now 3, it's going to change to 5. And local variable right now is a 5, which is this input. And the call data, as you can see, is the 4 bytes of the hash of the function, which we call selector, followed by the argument, which is another 32 bytes, 5, the input, the argument, okay? And then the stack also store the functor as the selector, and then the 5 over here. And then let's go forward here, push 0, give me 2, step 1, install. Okay, so that basically, I think I'm going a little too fast. Did I miss something? Okay, here's the instruction I need to. So here, line 111 is a very important one. So as we can see, we have a swap one. Swap one is going to swap these two on the stop. So we swap it. And then it's going to be, so this will be interpreted slot 0. And then this is a value we have to start on the slot 0. So which is going to be performed by 111. So this is the line is going to change this to 5. Okay, so it's changed to 5. So after that, then very much we're done. We just clear up the and then the last one we start with stop. So when you stop means the whole thing is done, right? So last thing I want to demonstrate is this one. So it's going to retrieve 5, but how is this going to be done? If you debug again, if you look at the cost data, we don't have an argument. We only have the 4 bytes of hash of a function. Stack is 0, memory nothing. Okay, again, we're going to start with push 8040 to set the initial offset of the memory to 80. Okay, so we store 80 to the address of 40. And then again, we're going to check if the amount of Italian sent is 0 or not, which is not. So now we're going to jump to the right position. And by the way, anywhere you jump, you have to start with jump destination. So it's a placeholder for a safe landing of a jump because the virtual machine doesn't want you to jump around to illegal place. Okay, so and then the call data size is going to check the call data size over here. Okay, I'm going to go faster. So I want to show you this instruction. So the next instruction is load is going to load from, now we're going to push 0, 0 because we're going to load from slot 0. Okay, so we push 0, 0. Now it's the state is 0, 0 now. And then the next instruction is load is going to read from the slot 0. Okay, into where? Into this location. So this is the location we're going to read to. This is 55. In decimal, it's going to be 5 times 16, 85. Okay, so we're going to pay attention to that. And then we dip to, again, we jump, and then we push 40, because we are going to load here. So we're going to read from 40 because we want to know where we can, where's the free memory. So we are going to read from the free memory at the location 40. So here is, remember, so we're going to read here, which is 80. So that means the free variable, the return variable, is stored at 80. Okay. So 60, and then I'm going to go a little faster. Okay, so this I need to also port M store is going to store in memory. So very much we're going to store this value 5, which is the value we returned here at location 80, because 80 is where the memory is available. So this is the one that save the return value. Okay, and then we eventually just very much clear up the step before we complete our final step until we reach line 104, and then the whole virtual machine is completed, the operation. Okay, so that very much explains how the EVM works. Thank you so much. I hope you can do some experiment yourself and understand everything better. Have a nice day.